Hi there, I'm Dylan, and in this presentation I'll be discussing Lab 1. In this lab we will observe the motion of an object moving at a constant speed without a change in direction. To do so we will use the motion of a marker rolling across a table to confirm the relationship between position, time, and velocity. This resulted in a linear relationship between position and time, and a constant relationship between velocity and time. The main concepts used will be displacement, velocity, and acceleration given a time. Displacement tells us the change in position, calculated between the difference between the final position and initial position. Velocity gives us the change in displacement over a given time, derived from displacement with respect to time. In this experiment, we'll use the formula for average velocity since the force applied is constant. Recall the acceleration is 0 because the velocity is constant. Some more things to consider are the system being the marker and the surroundings being the table, the earth, and my hand. The initial conditions include the displacement, which came out to be 0.149 meters in the positive x direction, and the time the marker took to roll across the table being 0.602 seconds. In this experiment, I filmed myself rolling a marker across a table. The tracker video shows the motion of the marker and a graph of position versus time. In the GlowScript editor, I made sure to change the time constraint and the x component of the velocity vector to match the conditions of my video, as seen in the lines highlighted in red. The dotted blue line represents the actual displacement in the video using the tracker data, while the faint orange line is the line of best fit representing the prediction based on the GlowScript data, both measured over the time interval used in the experiment. As witnessed, the actual data has a minor oscillation, perhaps due to friction by the table. The alignment of the axes might not be exact, therefore the overall points of position may not be exact either. Thus, the orange line would be what the motion of the marker would have looked like had there been no errors made by the surroundings and data formulation. What if the axis used was the negative x-axis? To put it simply, how would the results change if the axes were flipped? To answer that, we must first clarify that in the experiment, going to the right was the positive x direction. So if the axes were flipped, that would mean that the displacement, and in turn the velocity, would be negative since the marker would now be moving in the negative x direction. What does it all mean? I would say that it is possible to say how many pushes and pulls are added together to give zero net force. The push by my hand was negated by the friction of the table and air resistance, thus making the acceleration of the marker 0, as also shown in the velocity versus time graph. And that's it. Thank you for watching, and I hope you enjoy the rest of your day.